Hello everyone. Today our topic is why we need to use multiline equal to false by default while reading JSON files. So while reading JSON files, we'll write the syntax like spark.read.json and we'll mention schema, and in options we'll mention multiline as false. So generally by default, this is the default option. Whether you can mention like option multi-line as false, or you can omit the option. If you omit the option, by default Spark considers multi-line as the false. If you require multi-line is as true, then you need to explicitly define this option as true. So today we are going to discuss why this is the default option and why not true as the default option. So generally, while Spark structure like Spark is distributed system and Spark reads data by splitting files into chunks. So chunks means partitions. So whatever the file, whether it is JSON or CSV or Parquet or Avro, any kind of format file, when you try to read in Spark, first thing what it does is it splits into number of partitions and processing those chunks in parallel across executors. So that means if this particular file, it is splitted into 10 partitions. So each partition, it is sent across to different executors and all executors will run in parallel. Okay, so that is Spark parallelism. Next, why we need to use this one default. So whenever multi-line equal to false, that is the default option. So generally this option, no need to mention here, as I said here. So no need to mention. If you mention also, that is fine. But generally, no need to mention. If you don't mention, Spark by default considers as false. Okay, this is the default option. And what it does is, whenever you mention this, whenever Spark considers multi-line as false, what it happens is each line is a complete JSON record, and Spark can safely split the file anywhere. So each partition can parse JSON independently. So that means, suppose you consider this is our JSON file. So this is a single line JSON file because so each JSON object, it is in single line. If you see starting and ending is floor brackets, and inside that each and every key value, it is in single line, and we don't have any commas in between. So we'll call this as single line JSON. Okay, so and here each line, no, so starting and ending with the floor bracket, that will call as JSON object. Whether you can call as JSON object or JSON record. So here I have three JSON records. So generally, how we'll read this JSON file is, first we'll define the schema explicitly by using struct type. And if you see here, ID is the integer values. So ID, column name is ID, and the data type is integer type. And this is true. And second column name is name. So that we have string values. So data type is string type, and this is true. And third column is salary, and this is integer type and true. And this schema we are passing here. So how we'll read generally JSON file is spark.read, and if you're explicitly defining the schema, we'll mention dot schema, and inside that we'll pass this parameter. This variable will pass here, and dot option multi-line as false. So this is the default option. Since it is a default option, no need to mention here. If you are mentioning, that is fine. It's nothing wrong with that. But if you don't mention also, if you don't mention this, Spark, what it does is by default, it considers multi-line as false and dot JSON and this path we are providing here. So this JSON file path we are providing here. So instead of this, what I'll do, I have one single line JSON file. So I'll try to read here. So if I go to catalog and Azure ADB, try PySpark, training, and under training JSON, and I have single line JSON, single line. Okay, this also fine, or otherwise read JSON, single line. Okay, so if I show you this one, single line JSON, so we have from here to here, this is one single line JSON object. This is one single line JSON object. So like this, we have multiple JSON objects. So here what I will do, I will copy this path and I will try to read here. So this, I will remove this because, so wherever I have path here, no JSON. So here I will provide the path, JSON path. And df, what I'll mention, default I'll mention. So first I will try to print this one, like display this one and print this one in the scheme. So here, whatever for data type, I'm importing all these data types here. So this is fine now. If I try to run this one, so I will remove this one. Otherwise, what I will do, I'll do next. Okay, so what I already showing, no file for schema. Okay, so this schema is different now because this file is different, right? So I need to change my schema for this. So source, so first column name is source and that is string type, and second column is description. So without this schema also you can read with the info schema true option, you can read that also fine. So description, string type, step input timestamp. So this is a long time. So this one I will import from here first, long time. And my next data type is after input timestamp. I have last update timestamp. So this also long time. And I have country 2, that is the string type. And I have one more column. So that is user. So this also string type. User string type. So now it will read correctly. So no file system for schema null. Uh, file. Okay. So I'll remove this one. Okay. So now, so the thing is, first I, I read by keeping this option multi-line as false. So without keeping that option also can read it. So we'll get same output. So if you remove this one, what Spark does is Spark default constants uh, multi-line as false. So there is no difference between in your output. So Spark work on both the ways. So whenever you are going to mention as true, then only you need to define this option explicitly. Option multi-line as true. Okay, so now this is our JSON and this is the schema we defined. So now what happens is, so initial example, I took this one, right? So these three JSON objects I have. So what happens is Spark can different. So Spark can give different lines to different partitions. So each partition can parse its lines independently, which makes reading faster and scalable. So that means if I take this example, you can take this example also, both are same. So for simplicity, I took this example. Here I have three JSON objects and each JSON object will go to different partition. So for first JSON object, it is going to partition one. Second JSON object, it is going to partition two. And third JSON object, it is going to partition three. Okay, so this is about when you mention multi-line as false. So next thing is what happens if multi-line equal to true. So for this, I took a small example. So in this small example, here I took multi-line JSON. So here, whatever I took this example is single line JSON. So this is single line JSON. And whatever example I'm going to show here is multi-line JSON. So why it is multi-line JSON is whatever inside JSON object. So each key value pair, it is represented in separate lines. And on top of that, between each JSON object, it is separated with comma and starting and ending enclosed with square brackets. So this how it looks multi-line JSON. So this is my multi-line JSON. And this JSON, if I mention multi-line as true, what I'll get problems is one JSON record spans multi-line, multiple lines. So that means this is one JSON object. So you can say JSON object or JSON record. So this is one JSON record. So it spans multiple lines. So that means if you see earlier case, see here all the records it is in one line. But in case of multi-line JSON, it is span into multi-lines. So here we have only two key value pairs. So it is two lines. Suppose if this particular JSON object, suppose you consider this example, see here how many key value pairs are there. So 1, 2, 3, 4, 5, 6. Then it is spanned to 6 lines. 6 lines it will come. Okay, so that is one issue. Next one is Spark cannot split the file arbitrarily. So if Spark want to convert into multiple partitions, so up to here, it cannot be separated. Okay, since it is multi-line. So Spark must read large partitions into memory, coordinate parsing across lines. So what Spark need to do is the entire JSON file need to read. The entire JSON file need to construct into one partition. So that becomes large partition. So when it considered as single partition, what will happen? So it will become slower and it consumes more memory and harder to parallel. So that will happen when you define multi-line equal to true. So next, why not make multi-line equal to true as the default option? So now what is our default option while reading the JSON file? So since we are not mentioned here, but still Spark what it considers option multi-line as false. So this is the default option. But here, what is the thing is why we are not considering true as the default option? Because it would break performance for 90% of use cases. Spark would need to read entire files, reducing parallelism. So streaming and big data workloads would suffer. So why need to read entire files? Since I mentioned here, so Spark cannot split the file arbitrarily. So it need to read large partitions. So if you mention by default option as multi-line equal to true, then what will happen? These are all the problems we'll face. Next, what is safety and fault tolerance? With multi-line equal to false, what will happen? If one line is correct, Spark skips or flags it. So other records are still processed. So this will see what it means with the example. And second one is with multi-line equal to true. What will happen? One corrupt block can break the entire file. So these two things we'll see with some example. So first we'll see with visual explanation. So this condition is for multi-line equal to false. So here, this is my JSON file. So in this JSON file, I have 4 lines of JSON objects I have. So in first line, it is totally fine. I have clean JSON object. And second line also, I have clean JSON object. And third line, I have some corrupted record in my JSON object. And fourth line also, it is fine. I have clean JSON object. So now, in this case, what will happen? Whenever you mention multi-line equal to false, what will happen? First two clean records, it will read successfully. And whenever it comes to corrupted record, what will happen? It will skip this one and it will go for next one. Since the next one is clean record, it will uh, display in your result. Only it will skip correct record. But in case of multi-line equal to true, whenever you mention true, as soon as it finds this correct record, what will happen? It will read only these first two JSON objects. And as soon as it comes to this correct record, what will happen? It will fill all null values related to columns, and it will create one new column that is underscore correct underscore record. Under that column, this entire JSON file, it will dump into that particular column. So that I'll show you in below example how it will dump. So that means the whole file is rejected. So corrupted records are only added to the corrupt underscore record column. So this is the column I told. So Spark by default creates this column underscore corrupt underscore record. So whenever it finds any corrupt record, Spark automatically creates this column, and whatever we have corrupted records, it will move under this column. If a JSON parser encounters incomplete malformed JSON data. So here, line 3, that is third JSON object, since that is corrupted record, so that record, it will move under this particular column. And next, if the record simply has type mismatch or missing columns, so those are not considered correct and will not be placed in correct underscore record. So type mismatch means data type mismatch or missing columns missing. So those things it won't considered as corrupted record, and it won't place under correct underscore record. So instead, Spark will fill those fields with nulls in permissive mode. So that means whenever you read JSON file, you need to pass the parameter like dot option mode as permissive. So that means if any corrupted records in your JSON file, this permissive mode, what will happen? It will allow you to read the JSON file and display the JSON file. If you don't pass this parameter, what will happen? It won't allow further. It will throw you error. Okay, and these modes, permissive modes, we have three different types. So those three different types, I already made one video on how to handle bad records by using these three different modes. So you can watch that video, you will get idea. So only truly malformed records, like example, broken JSON syntax, are captured in underscore correct underscore record. So now we'll see this whole thing, how it looks with some scenario. So scenario one is with multi-line equal to false. So if one line is correct, Spark skips or flags it. Other records are still processed. So you consider this is my sample JSON. This is single line JSON uh, file. And see here, each line has each single JSON object. And if you see here, first three are clean JSON records. So that means as per JSON thumb rules, it is satisfying. But whenever if you come to fourth JSON object, and if you see here, here it is missing closing flower bracket. So that means it is not following JSON standards. So this it considered as corrupted record. So line 4 is correct. What is the issue here is missing closing flower bracket. So this is the one example of how corrupted record. And next, if you see fifth JSON object, it is clean record. So now this particular thing we'll see here how we need to handle here. So here first I'm doing what I'm doing here is I'm defining the schema. So how I'm defining schema is first one is schema without corrupt record. So that means if your JSON file has these three columns, then generally we'll uh, create explicit schema only for those columns. But if you mention, if you pass only these three columns, and if you have corrupted records, then whatever we have this column, no default default column, that is underscore and underscore corrupt underscore record, that won't generate if you do like this schema. So what you need to do is you need to add this column, this struct field you need to add by mentioning this column underscore corrupt underscore record, and this should be always strict type. So then only this column will get add in your data frame whenever you have corrupt record. So now this is the schema. Next, what I'm doing, permissive mode and explicit schema without corrupt record. So that means, as I told, modes will be three different modes. So in that we are using one mode, permissive mode, and we are defining explicit schema without corrupt record. So that means this one. Without corrupt record means this one. Schema without corrupt record. So that means this particular column I'm not passing here. So this example, we'll see what will happen if you don't mention this particular column in this schema that I want to show here. So if you provide an explicit schema means this one, explicit schema. Manually providing the schema means that is explicit schema. So Spark will not add new columns that are not in the schema. So that means even though we have some other columns, some other additional columns, it won't generate unless you mention in this schema. So that is this one. So schema does not contain corrupt underscore record. So reads valid rows correctly. For corrupt lines, fills all defined fields as nulls, drops the corrupt text because there is no column to store it. So whenever corrupt record comes for all the columns, suppose these columns, ID, name, price, it will print like null, null, null. So this I will show you here. Like, so first what I'm doing, as I said, schema that is without correct record schema I'm passing here. And as I told, mode I'm passing permissive. So that is this one. So one condition is this one, permissive mode. One more is explicit schema. So mode I mentioned here, permissive schema, and one more is explicit schema, that is this one, and one more is without corrupt record. So in this, since in this schema, since I'm not mentioned corrupt record, that is this one. So this is the path of my data set. Training, read JSON. So training, JSON, read JSON, single line, correct record. So single line, correct record. So this is the path I want to pass here. So I will update this path here. PySpark training, read JSON. PySpark training, read JSON. Okay, so this is fine. Okay, and if you see this particular file where corrupt record is for same example, so here it is missing closing flop, right? So if now if I try to read this one, first I need to define this one. I need to run this one, this schema. Now I will run this one. Okay, so how we are getting here is, so this I'll move down at one place. Okay, so still one more down. Still one more down. Okay, so this is schema. This schema I'm passing here. So whatever we are discussing as of now, what is the thing is, so first we'll discuss about this. So whenever you don't mention this corrupt underscore record in our schema, here what we discussed is if you provide an explicit schema, Spark will not add new columns that are not in the schema. So schema does not contain underscore corrupt underscore record. So since we don't have this column here, what it gives output is, see here, first three records are fine. They have clean records. And if you come to fourth record here, so we have corrupted record. So what it doing for corrupted record, the all the columns it filling with null value, and this corrupted record, generally what it should happen is this column should have created here. That means one additional column should have created here, and this whole JSON object you should dump under this area. Since we are not defined here in this schema, so what it doing, as I said here, it will print only nulls here. And to the corrupted text, no, so since there is no column to store it, so it not giving anything output here, so it giving only nulls. So that is the thing about mode permissive and schema without this corrupt record uh, schema. So okay, this is fine. So next, mode is same, permissive mode and infer schema. So infer schema means, so here I defined schema, right? So here what I'm doing, I'm trying with infer schema. That means I'm not passing any explicit schema. So suppose if you want to read by default Spark means what we need to do, we need to omit this one, so that what will happen if you don't pass any parameter related to that, what will happen, Spark or by default considers infer schema as true. So now what will happen, so I will change the path. Okay, so this also will rearrange little. Okay, so it is auto schema inference. That means inference schema as true. So if you remove dot schema from previous case, Spark, what will happen? Spark will auto add this particular column. This column, it will automatically add. Okay. So not recommended for production. So this infer schema is true, this option. So it is not recommended for production releases. It is always recommended to define with explicit schema. So now what will happen if you run this one? If you compare previous output on this one, see here, this column is Spark by default, it added. So as soon as it finds some duplicate records, not duplicate, corrupted records, what will happen? Automatically it adds this column underscore corrupt underscore record. And for all your clean records, here it will fill with null. And so wherever you find corrupted record, so due to corrupted record, it printing nulls, and that particular JSON object, it will dump here. And if you see here, by looking this only, you'll come to know here there is no closing floor bracket. Okay, so this is about infer schema. One is infer schema. So that means without passing explicit schema. So this is the thing we are discussing about this one. So underscore corrupt record and so here. So corrupted records are only added to underscore corrupt record column if the JSON parser encounters all form JSON data. Okay, and these are the conditions. So it Corrupted record means, so not data type mismatch or missing columns. It is only the things like this kind of things. So whatever I explained here theory, so everything now coming under this example. So this example exactly matches to this condition, whatever we just now ran. So their third JSON object is corrupted record. What it done, it skipped that particular uh, JSON object. It filled all the null values, and this corrupted record JSON, it dumped under that column, and it proceed for remaining columns. So that is this one. See here, even though here corrupted record is there, so what it did, the corrupted record, it dumped under corrupt underscore record, and it proceeded for remaining JSON objects. So valid rows are processed and corrupted lines is skipped or flagged. So flagged means here. So it flagged under corrupt underscore record. And one more thing here we used dot option mode permissive. So permissive mode means what it is. It reads all valid JSON records for malformed JSON, sets all normal columns to null, stores the raw corrupt JSON text in special column. So that is this one, corrupt underscore record. Okay, so how we are getting this column and all these things is due to this one, mode permissive, dot option mode permissive. So that is this one. All these things explained here. And one more is permissive mode, explicit schema with corrupt record. So that means this schema, what I will do, since this scenario is only limited to permissive mode and explicit schema without corrupt record. So what I'll do, I'll remove this part. I will keep only explicit schema. This is explicit schema without corrupt record. So that means we don't have corrupt record here. Otherwise, I'll keep to understand correctly. So permissive mode. So here. So if you see here, permissive mode and explicit schema here with corrupt record. So with corrupt record means this one, with corrupt record. In this explicit schema, I am adding this column. So since I added this schema here, now what will happen? I will copy this path. Okay. So what is same permissive? So here only difference is schema. So we are considering this schema which has corrupt underscore record. So if I run this one, null. Okay, I need to remove one backslash. So earlier what happened? So if I go here, see when I defined this one, no schema without corrupt. So here we don't have corrupt record, right? So here what happened? Only the JSON columns are printed. So that additional column is not printed. But here, since I mentioned in schema, so I'm getting this column, this additional column I'm getting, and it's showing these nulls here and that bad record it dumping here. And one more difference. Since my schema is defined in this order, ID, name, price, correct and underscore record. So same way I will get columns also like ID, name, price, correct underscore record. But if you see in previous case, so previous case is what? This is infer schema as true. So this is infer schema. That means schema we are not defined. Infer schema equal to true. So for infer schema equal to true, no need to add in these options. So by default, Spark considers infer schema equal to true. So whenever you define, it considers infer schema as true. And on top of that, we are reading JSON file. So with infer schema as true, and we are reading JSON file means JSON files, whatever we have data here, that is columns, that is these columns. See these columns, no? Suppose this is one JSON object. So inside JSON object, we have key value pairs. So in this, each key is the column. So here, how is the order? Source, description, input, timestamp. I think one more bad correct record. So here, ID, name, price is there. If you see order, no, column order. So first ID is there, then name is there, price is. So whenever you read JSON file with infer schema as true option, there is no guarantee that it will come in same column order. So ID, name, price. So ID, name, price. So but here we are getting correct underscore record as the first column. But as soon as you defined your schema, as soon as you defined with schema, so it will follow the same column order, ID, name, price, correct underscore record. So that is the reason this particular column, correct underscore record, it coming at the end. Okay, so correct row is isolated and clean data is not lost. So that means even though here we have correct record, it proceeded further. So that uh, bad records, it dumped here and it proceeded for further clean record. So this is about default option, that is, uh, so here we defined multi-line as false. So as of now, what we discussed is multi-line as false. Okay. So in case of multi-line as false, what will happen? Even though if you have bad record, it will continue. It will continue further. In same scenario, in same scenario, I want to show one more option like, say Spark, it is giving by default this column name, right? Underscore correct underscore record. Suppose I want some different name, then what to do? So when does column name of corrupted record matter? So it only matters when you change the column name. So this schema option mode permissive, we already saw. Here, what added additional option is option column name of corrupt record. So when we need to use this option is, suppose you don't want to use this Spark default column name, that is underscore corrupt underscore record. So you want to use some other column name, suppose like bad underscore record. Then what you need to do, you need to define the schema here. In schema, you need to define your own column name here. And this schema you need to pass here. And second thing, you need to pass this option like column name of correct record as bad record. So whatever you passed here, column name, that you need to pass here. So now what will happen? So instead of correct underscore record, you will get bad underscore record. Okay. So if you run this one, what you'll get? So instead of correct underscore record, you will get bad underscore record. So remaining everything same. So only the changing the column. See here, correct underscore rows goes into bad underscore record. So correct underscore record is not used. Okay, so next is what if schema has correct underscore record, but options uses different name. So that means this schema is said schema with correct. So schema with correct. So here schema with correct, what we mentioned, correct underscore record. So here I define column name as correct underscore record. But here in option column name of record, here I'm mentioning as bad record. So that means here one name is there one name is there. So what I'll do for easy access, I will copy this one and paste here. So this is the schema I'm passing here. So in explicit schema, I mentioned as underscore correct underscore record as the column name. But by mistake or intentionally, if I mention my column name here as bad underscore record. So name is conflicting here. So for this case, we'll see what it will happen. So this path also I will change. So if I run this one, what will happen? Since my explicit schema says corrupt underscore record, it considers the column name as this one, corrupt underscore record. But since in these options, since we have different name, what will happen? It will print all null values. Okay, that is the thing you need to remember. If you have different names, it will print nulls here. Okay, so Spark will not write correct data because bad underscore record is not in the scheme. Next, how to create separate tables like clean and bad data. So if you want to filter it out, suppose if you see here, in here, this table, we have both clean data and bad data. Suppose if you want to segregate, so only clean data in one table and bad data into other table. Then how you can do is, this is our output, that table. I'm using filter option, filter function. And what is our column name? Underscore correct underscore record. So here I'm giving condition like is null. So that means in this correct underscore record column, so if it is any nulls, then it will filter only those records. So if you see for first condition, so correct underscore record is null. So here, this is bad record, correct underscore record, this one. So here, what it telling is null. So is null means, so these four we have nulls. So what will happen? So it will print only these clean records, these first three and these five. So 1, 2, 3, 5 it will print. If you see the filter condition for first filter condition 1, 2, 3, 5. So only clean data it will print. And finally, what I'm doing, if I don't use this drop, no, what will happen? That column also will get. Suppose if I try to add one more line of code to show that one, valid data with, I'll mention as width, and suppose I'll remove this one, and I'll try to display this output also. So if I run now, let's see the difference. You'll get that column also for this one. See here, for first one, we are getting this corrupt underscore record. So actually we filtered based on this corrupt record. So wherever null is there in this, so we are filtering only these records. But for our final uh, project purpose, we don't require this column later. So that's why we used to drop corrupt underscore record. If you see in second output, you don't see this one. You will see only this clean data columns. Okay. So next, bad record. So now the condition is opposite, like is not null. So is not null means if you go here, so here, this is the one record which satisfies correct underscore record is not null. So this is the not null value. So this one particular record, it will print here. See here for this condition, it will print this one. So this one particular row, it will print. So this how you can segregate clean records and bad records. So next is why this works. So that means multi-line equal to false. So that means one line, one record. Corruption affects only that line. So Spark continues processing other lines. So since we mentioned multi-line as false, what it means? One line has one record. So if bad record is applied to only this particular line, so what will happen? Since it affects only this line, so it will dump in this column and Spark continues processing other lines. So now we'll see scenario 2 with multi-line is true. So here one corrupt block can break the entire file. So that means if you see here, this is first JSON object. So this is fine, clean record. Second JSON object, this also clean record. Third JSON object, this also clean record. But when you come to fourth JSON object, since um, since we commented here, so what it considered as corrupt block. So I commented like this. So that is the reason it is corrupted record, and this is fine, and this JSON object is fine. So now we'll see by using multi-line equal to true while reading this JSON file, how the output comes. So here, what is the issue here is, in earlier case, we missed this flower bracket. But in this case, what is the issue here is JSON comments. So whatever this backslash is there, no double backslash line are not allowed inside JSON objects. As per JSON thumb rules, we should not have any comments here. So due to this double line comments, so the entire JSON object getting invalid. So invalid comment. So here don't confuse. Here invalid thing is this one. Double backslash is not allowed. So this I given comment into invalid comment. That means this is the correct block. So this corrupts the entire JSON array. So that means because of this one comment here, even though you commented only for this particular line, so it affect for entire JSON array. So entire JSON array means this whole JSON array it will affect. That means the whole file it will affect. So to show this one, we are defining the schema ID name price. So explicit schema, that is I given name as schema true, that I'm passing here. And here I'm defining option multi-line as true. Since it is true, since we want true, we always need to define. If it is false, no need to define. And mode as permissive. And I will change this JSON path. So I will change to this one. Okay, read JSON. This is not the same file. So what I need to do here is read JSON multi-line character. So this is single line JSON. What I supposed to go is multi-line folder. So multi-line character. So this is the file. So I'll copy this path. First I'll copy this path. Then we'll see the JSON file, how it looks. This same thing only, whatever we discussed, the same thing I'll open here. So multi-line character cut. See here. So same JSON file I'm using here. Because of this commit, it is corrected record. So if I run this one, what will happen? So first I need to define this one. Then I need to run this one. So one thing is this connect underscore record is not adding due to here in explicit schema, I'm not added that column. So due to that, it is not come. But as per JSON file, first three records are clean data. So it printed three clean records. Next, fourth is the corrupted record. So as soon as it hit corrupt record, so it printing nulls, and that down it is not keeping here due to this column is not available because schema it is not mentioned. And one more observation. After that, we have one more JSON object that is good data. But due to this multi-line as true, it not moving further. It is stopping here on. So that means it considering as entire JSON object as corrupted. So I will show you in next. So here, what is the result? Spark fails to parse the JSON. Output is either empty data frame or single row with all nulls or job failure, depends on the Spark version. So in these options, what we are getting is so the row we are getting with all null values. Okay, so this is one. And second one is here in this explicit schema, I'm adding this column, corrupt underscore record column, I'm adding here. Since I'm adding, I'm keeping here also. I think this is not required. If you want same column name, so you can omit this one. This is not required. That is required only when if you required different column name. So now what will happen since we added this column in schema, this underscore correct underscore record column will get add. So before that, I'll change the path. Okay. So since this column is added, so we are getting this column and this fourth is the since we have corrupted record, this one. So what it doing? All the corrupted record it dumping here. And if you try to expand this one, the entire JSON, it will paste it here. See here, even though fourth JSON object is corrupted, but it dumping the entire JSON file. Okay, and entire JSON file it dumping here, and it not proceeding further. Even though in fifth JSON object we have clean data, it not going further. So this is the difference between multi-line as true and multi-line as false. Okay, so mainly in case of corrupt record. And two scenarios we completed, multi-line as true and multi-line as false. Next one is, so what is our final conclusion is single line JSON. So single line JSON equal to one row per line. That is like CS. So single line JSON initially we saw, right? So read single line JSON. So this is this one, single line. Entire JSON object will be in single line. So that is this one. So multi-line JSON, one book spread across many pages. So this we saw just now, multi-line JSON, how it looks. So Spark prefers rows, not books. Okay. So prefers rows means it prefers this one, single line, but not books means this one. So what is our final takeaways? Multi-line equal to false is default because it enables Spark parallel, scalable, and fault tolerant design. Use multi-line equal to true only when your JSON truly spans multiple lines. Okay, so that's all about this video. Uh, why we need to use why multi-line equal to false is the default option while reading JSON file. So if you really like this video, please like and subscribe. Thank you.